One thing my students struggle with is realizing that all of these numbers are the same. How is all of this the same thing? Let's talk about it. First of all, the easiest one to realize is that 1/5 is a division symbol. I tell my students, look at it. Okay, it even looks like a division symbol. Look at this. Look at this, 1/5 or whatever. So a fraction is division. So turning this into this should not be a stretch. 1 divided by 5. 1 divided by 5. Turning it into a decimal is a little bit harder, but we're going to stick with this whole thing, right? So 1/5 is 1 divided by 5. It is 1 divided by 5. It looks backwards to many students because usually they're putting the bigger number underneath, but we have to train their brains to think differently. No, when you start counting by fives, the first number you're going to get is a 5. So this does not work. But numbers go on forever. So we can add a decimal after our 1 and just continue to count. Now we can look at this into a 5 into 10. 5 into 10. We're using the 10, so I'm going to go ahead and pop this decimal in my answer. There are other ways to do that as well. But 5 into 10 tenths, well, 5 times 1/2 is 10. Okay, so 5 times 2 tenths is 10 tenths. Let's go back to the beginning. So now we've shown that 1/5 is 2 tenths, is also 1 divided by 5. So now the question with these guys, these zeros, let's talk about that. I like to call this captured zeros. So we said that 1 divided by 5 equals 1 divided by 5. And we added this and we got, but then you'll see answers that look like this. This is 2 tenths, this is 20 hundredths, and this is 200 thousandths. And what's confusing is that, again, these are all the same numbers. So that's when I talk about captured zeros. Zeros sometimes mean just that. They mean 0, and other times they hold place value. So if your 0 is not captured, it means 0. It does not count. The only way that a 0 can be captured is by a decimal or by another number. So for example, there's a decimal here, but there's nothing in front of this number. This 0 means nothing. It's not captured. It needs to be surrounded. Okay, this 0, again, it's not captured. There's no number here. So this 0 means nothing, making it equivalent to this. This 0 means nothing, making it equivalent to this. This 0, there's nothing in front of it capturing it. This 0 is captured by another 0, which does not count. Let me give you some actual examples of how this works. So recognizing when a 0 is captured, right? So if we have, 1.207, this 0 is captured because he's in between two numbers. This 0 holds value because it turns it from 27 into 207. So this 0 matters. It is captured by two numbers. Now this 0 is not captured because there's nothing over here capturing it, and it's at the end of a number. Zeros at the very end or zeros at the very beginning of numbers don't matter. Then I like to give my students something like this, and I'm like, okay, which zeros are not captured? This 0 has nothing over here capturing it. This 0 is captured by the 3 and the 5. This one counts. This one has nothing capturing it. So this is the actual number. These zeros don't matter. You can add zeros, forever. Now we've also talked about a leading 0 and a 0 on the end that's not captured. And the last one is the percentage. Get from, 1/5 to 20%. Again, I would start with 1/5 equals 1 divided by 5 equals 1 divided by 5, and we decided that was 0.2. So now when you're changing this to a percent, what you do is multiply by 100. And the reason why you multiply by 100 is because you're saying this is so many out of 100. So if I take 0.2 and I times it by 100, you're just moving this the value of this number by two place values. So if I have 0.2, if I move it by one place value, that's going to be 2. If I move it by two place values, that's going to be a 20%. When students are learning this, I find it valuable sometimes to, draw a place value chart. This helps them understand. So this is what you're moving this guy by two place values. This is not a place value. Okay, decimals aren't a place value. These are place values. You're moving it by two place values. So 1, 2. 2/10 times 100 is 2/10. 2/10 is 20. So this is the last way. So all of these numbers are the same, and creating this concrete understanding of 1/5 is 2/10 is 20%, can have a leading zero, is also 1 divided by 5, and can have, can be 20 hundredths or 200 thousandths. This creates necessary understanding to move forward in math. I hope this helps.